Okay, in this video we're going to use Excel to conduct a couple statistical tests on some hypothetical data. We have two treatments and we're treating a disease, and initially people have the scale we're using for the disease is 0 to 3. 0 they don't have the disease, and 3 they have the disease, and it's the severest form. Okay, so here's before. So these 10 people we chose randomly, and before, this is what they had as far as the disease was concerned. We gave them the treatment, and this is what they have after. And I want to see if this after is significantly different from before. So for this one, we want to conduct what's called a paired t-test, and it's paired because each of these pair of data represent a person or subject, and so each column of data is not independent. They're dependent sets of data. So that's important, that it's a paired t-test. And we have to state what's called a null hypothesis, and the null hypothesis is going to say the mean. I'm just going to use some words here. The average for before is equal to the average of after. Okay, that's the null hypothesis. Is no effect of this treatment. And the alternate, which I'm going to label ALT, is let's say that the after is actually less than before. In other words, the numbers are significantly less than before. So the after is less than before. Or if you want to say the before is greater than after. So we could also write it this way, as the before is greater than after. Okay, so just note that that does matter which symbol we put there. That's a one-tail test. If I just wanted to see if there was a difference, we would say not equal to. But I'm saying before is greater than after. Okay, so when we do this test, what we're going to look for is a p-value, and that p-value tells us the probability of getting these results afterwards. If that probability were low, but we did get these results, then what we do is reject the null, and we say there's a difference, that before is greater than after. In other words, the treatment is effective. If the p-value is high, then we don't reject the null, and so we're saying the treatment's not effective. Okay, so how do we get this p-value? Well, we go into fx, and we have statistical here, and we scroll all the way down to t-test and click OK. And here it kind of leads you, tells you what to do. What we have to do first is highlight the first array. So I'm going to do, the first one is before, and the second array as after. And so I'm going to do what's called a one tail, and what it's going to do is going to do before minus after. Okay, so before minus after. And so if that's positive, then we know there's a significant effect there. And the type is we're going to do a paired t-test. So I'm going to hit 1 here and click OK. And our p-value is the key here. So I did before minus after. Is there a significant difference between before minus after? And this is saying this probability is very small. It's less than 5%. It's 0.004 or 0.4%. And that means I have to reject the null. I should reject the null. There's evidence to show that the treatment's working, that the after scores are less than the before scores. Now, how this test is working is the computer is taking the difference of each of these numbers, it's doing before minus after, and then it's really conducting a single t-test on those differences. And that's how we end up with this p-value. So I'm going to do the same thing for the second treatment. Again, we want to do a paired t-test for this one, and I'm going to do that, and we'll see the results. So I did the test here, the second test, the same null and same alternate, and our p-value is 0.0222. And again, this is smaller than 5%. It's significantly smaller than 5%, so we're going to reject the null. Now, if we had used a different cutoff like 1%, this would be bigger than 1%, then I would not reject the null. So it really depends on the cutoff value you use. And usually in these tests, that cutoff value we call alpha, and usually that's 0.05 or 5%. Usually. Okay, so with alpha 0.05, we're going to reject the null in both cases, and so we're saying both of these treatments are effective. Now what we want to do is compare these treatments to each other and see which one's more effective. So to compare both treatments to each other, I'm just going to use the after columns. Just going to use these 2 yellow columns, and I'm going to test those to see which one is different. But because they're 2 independent samples we have here, we're going to do what's called a 2-sample t-test. So no longer a paired t-test, but a 2-sample t-test. And the null will say that B or A, let's say A is equal to B. The treatment A is equal to B. The effectiveness, I'm just shorthanding this here. And the alternate is going to say A not equal to B. Okay, so alright, again, so we're going to look for this p-value. And how do we do this? Well, again, we go to fx, we go to statistical, we scroll all the way down to t-test, click OK. And now this is really important. Array 1 is this, I'm going to do, treatment A is going to be array 1. And array 2 is treatment B. And the tail in this case, because I have a not equal to, because it says not equal to on the alternate, I'm not going to put 1 for tails, I'm going to put 2 tailed. All I'm interested in is there a different effect from both treatments? Is one working differently than the other? And now the type of test is not a paired t-test anymore, it's a 2-sample t-test. Now they have 2-sample equal variance and 2-sample unequal. I'm going to choose 3. Usually that's the case is unequal variance. Very rarely are they equal variance. In this case they may have been actually, but I'm still going to choose 3 because that's a little bit more conservative in my answer. So I click OK, and there's my p-value. So this p-value, what does it tell me? I have to now fail to reject the null. And why? Because it's the probability of me getting what I got, the differences between these 2 samples, is quite high. And so there's no big deal. I got this difference between these 2 is not much. So I can't reject the null, and the null says there's no difference between these 2 treatments. Okay? So we did 2 different types of tests here. We did a paired t-test where you have dependent samples, and then we did a 2-sample t-test. And note, with a 2-sample t-test, the sample sizes do not have to be the same because they're 2 independent samples. In this case they were, but they don't have to be. But the key is they do have to be independent.